Hello, I'm Priyanti Ismail and I'm here to discuss with you what is mathematical induction in data structure all about. Now let us start. It is a mathematical proof technique. It is essentially used to prove that a property of n holds for every natural number. So n could be 1, 2, 3, and 4, and so on. Have you heard about domino effect? So when any domino falls, the next domino falls. So all dominoes will fall, and that's how mathematical induction works. So the principle of mathematical induction is a useful tool for proving that a certain predicate is true for all natural numbers. It cannot be used to discover theorems, but only to prove them. So guys, the method of mathematical inductions requires two cases to prove. The first case, called base case, or sometimes the basis case, proves that the property holds for number 0. The second case is called induction step. That proves that if the property holds for one natural number, then it holds for the next natural number, as presented as n plus 1. So these two steps establish the property of n for every natural number. So n could be 0, 1, 2, 3, and so on. The base step can begin with 1 and not only with 0. Often it begins with the number 1 and it can be with any natural number. For these two steps, mathematical induction is the rule from which we infer that the given statement is established for all natural number. So here is the example of a mathematical induction. So let us prove by induction that 1 plus 1 plus to the nth number is equals to n times the quantity of n plus 1 divided by 2. So for the base case, let us show that p of 1 is true. So let n be equals to 1. So we must prove that the given equation is true. So now we substitute the given value of n into the equation. So on the left hand, the answer is already 1, while on the right hand equation, we need to simplify it. Now we perform the operation to prove that the left and the right hand is true. Perform PEMDAS on the right hand. So 1 plus 1 equals to 2. 1 times 2 equals to 2. And 2 divided by 2 equals to 1. Then it's true for the left hand equation and the right hand equation is 1. And that's how to prove on base case. So now let's move to induction case. In induction case, let us show that if p of n is true, then p of n plus 1 for any number that is element of natural number is also true. So this is the original equation. We add the n plus 1 to both sides of the equation. Now, we will simplify the right hand equation since the left hand equation is already in a simplified form. And this is the simplified form for the right side. Now, let's use the equation to prove that the p of n plus 1 for any number that is element of natural number is also true. Let us prove that the left and the right equations is still true for p of the quantity of n plus 1. Let n be equals to 1. Then we substitute the n into the simplified form equation. So this is our equation. Let us solve this. So as you can see, the left and the right equation is the same. Then we already proved that P of n plus 1 for any number element of natural number is also true. So the conclusion is P of n must be true for any number that is element of natural number. So that's how is mathematical induction works, by proof. So mathematical induction in some form is the foundation of all correctness proofs for computer programs. So the next topic I will be discussing with you guys is related to mathematical induction. So the problem will be proof using mathematical induction. So it's the celebrity problem. So what is celebrity problem? In a party of n people, only one person is known to everyone. Such a person may be present in the party. If yes, she or he doesn't know anyone in the party. We can only ask questions like, does A knows B? Find the celebrity in a minimum number of questions. The key definition to solve the problem, which a person is a celebrity if, number 1, this person is known by every other guest at the party, and number 2, this person does not know any other guest at the party. So let's solve this problem. There are 5 members in the party and their names are Maria, Jose, Michael, Juan, and Roland. So Maria knows Jose, Michael, and Juan. Jose knows Michael and Roland. Michael knows nobody. Roland knows Michael. Juan knows Maria, Jose, and Michael. So as you can see, Michael is the celebrity of this problem. Since Michael does not know anybody, but everybody knows Michael. So the solution to this problem is, we have this function, we called it as find celebrity, and we pass the list of members, and on this function we perform the while loop, and in the while loop we call the does know function. The does know function receives the source and destination parameters. So this function checks if source knows destination. If source knows the destination, then return true, else return false. The algorithm to solve the problem is, first, pick the first and the second element from the list. Second, check if the first element knows the second element using the does know function. If yes, then remove the first element from the list. Since first element knows the second element, the first element can never be a celebrity. If no, then remove the second element from the list. Since second element is not known by first element, the second element can never be a celebrity. A celebrity guy is known by everybody. So go to step 1 if size of the list is not equal to 1. And that's the algorithm of how to solve the celebrity problem. So the first iteration is we pass Maria and Jose to the does know function. So we ask Maria if Maria knows Jose. So Maria knows Jose is true. So we remove Maria from the list. So now the members that left are Jose, Michael, Roland, and Juan. And then for the second iteration, we pass Jose and Michael to the does know function. Jose knows Michael, so it's true. So we remove Jose from the list. Now the members list are Michael, Roland, and Juan. And the third iteration, we pass Michael and Roland. Is Michael knows Roland? So it false. So Roland will be removed from the list. And the fourth iteration, we pass Michael and Juan. Does Michael knows 1? So false. So we remove 1 from the list. Now, the members left only Michael. So size of the members is 1. So this is indicate that the loop has been ended. So we return Michael as a celebrity in the list of members. This is how celebrity problem use mathematical induction. So with mathematical induction, it shows that if there are n people at the party, then you can find the celebrity. If there is 1, 3 times the quantity of n minus 1 questions. So let P of n be the statement that for n people at the party, then you can find the celebrity with 3 of the quantity of n minus 1 questions. Given n equals to 4 at the party, so we can find the celebrity in 9 questions since we use the equation of 3 times n minus 1. So 3 times 4 people at the party minus 1 is equals to 9. So the base case here, given with P of 1, so notice that for n equals to 1, there is a single person at the party. Let's call this person Michael. There are no other people at the party. Therefore, Michael knows nobody else at the party. Likewise, every other guest knows Michael, since there are no other guests. So if we use the equation, so 3 times 1 minus 1 equals to 0. So there will be 0 question to us since there's only a person at the party. On the induction step, let us show that P of n plus 1 is true given P of n. So P of n plus 1 is true, meaning that for n plus 1 people at the party, you can find the celebrity with 3 times the quantity of n plus 1 minus 1 equals to 3 times n questions. So that's how the celebrity problem works. So let us proceed with the second problem, which is the knapsack problem. So the knapsack problem is a problem in combinatorial optimization. Given a set of items, each with a weight and a value, determine the number of each item to include in a collection so that the total weight is less than or equal to a given limit and the total value is as large as possible. It derives its name from the problem faced by someone who is constrained by a fixed size knapsack and must fill it with the most valuable items. So the problem scenario here, knapsack problem is similar how a thief works. Suppose a thief breaks in some shop having knapsack where he can carry only 15 kg. Now, there are so many items up to 4 kg, but he has to pick up items which gives him maximum value. Suppose items' weight and their respective values are given. So there are 3 types of knapsack problem. The 0-1 knapsack problem, the second one is bounded knapsack problem, and the third one is unbounded knapsack problem. So I will use the 0-1 knapsack problem for an example. So the 0-1 knapsack problem, items cannot be broken, which means the thief should take the item as a whole or should leave it. This is reason behind calling it as 0-1 knapsack. So the algorithm in solving the knapsack problem is to consider all subsets of items and calculate the total weight and value of all subsets. Second, consider the only subsets whose total weight is smaller than the capacity. From all such subsets, pick the maximum value subset. This can be achieved by using recursive tree or dynamic programming. And this will be discussed in depth on the other video. tutorial. So sample problem is, there are 4 items to be included in the bag with its equivalent weight and value. So as you can see, item A, its weight is 2 and its value is 1. Item B, its weight is 3, value is 2. Item C, its weight is 4, value is 5. And then item 4, its weight is 5 and then value of 6. So the total capacity that the bag can carry is 8. So we solved this using tabulation method. Before I show you the formula in filling up the table, we will do it first manually. The given capacity is 8. So we have column from 0 to 8. Then there are 4 items. To be picked up. So we have 0 to 4 rows. Then a table to fill up the values. On the left side, these are the given values in weight per items. Okay, let's start filling up the table. We have this start point, which is 0, because initially we will not include any items on the bag. So from the first row, there's 0 item. So what will be the value? This will be 0 since there's no value to be gained. Same applied with the column that there's no item can be added into it. For the first row, we get the first item. Since the weight of the first item is 3, we can only fill the values on the table when the capacity is at 3. What is the value of the item? It's 2. So we fill the table with 2 as the value. And for the column of 1 and 2, we fill the value based on previous value, which is 0. So for the column of 4 to 8, as you can see, the capacity is increasing, but we can only consider 1 item. Based on the previous item, the value is 2. Then the value would be 2 for the rest of the capacity. For the second item, we will include the value and weight of the first item. As you can see, I highlighted the first and the second item. Let's take a look at the second item. So its weight is 4. We can only fill the bag if the capacity is 4. So what is the value of item 2? It is 3, right? So we put the value 3 at the table. And the column of 1 to 3 is same value as the upper previous one. For the next capacity, we must consider the item we've included before. So now, we will consider the first and the second item. So the weight of the first item is 3 plus the weight of the second item is 4 equals to 7. So we will fill the column 7 with the total value added of first and the second item. So the total value of first and the second item is 5. So we put the 5 there. So for the rest unfilled capacity, copy from the previous values. For 5 and 6, we copy the 3 from the previous values. And for the 8, we copy the value from the previous column, which is 5. The same goes as the third item. So the capacity of third item is 5. So we can only fill the bag if the capacity at 5. What is its profit? It's 6. So we fill it the 6. So the capacity of 1 to 4, copy the values from the upper row. Now let's see. If I consider the third and the second item to be included, we add the weight, which equals to 9. But this weight is greater than the capacity, which is 8. Now let us take the first and the third item to be included. The total weight is now 8. this is equal to the capacity value. This means we can put the value on the capacity 8 with total values of first and the third item, which is equivalent to 8. So for the column 6 and 7, we will copy the previous value, and previous value is 6, right? And for the fourth item, we will use the formula. So let us use the formula. K represents a stable, col represents as weight, rho represents as item, and B represents as value. So the formula is area of K index row comma col equals to max of area of K index row minus 1 comma col comma K area of K index row minus 1 comma col minus area of col index row plus area of value index row. And that's the formula for filling up the table. Let's use the formula to fill up the value. So we substitute the value of row and col into the formula. So this is the output. So as you can see, there's negative 5 there, and there's no location that has negative value. And this value will become undefined. So only the value will define if that becomes the array of 3, 1. So we will copy the value of row 3, column 1 to row 4, column 1, which is 0. So this means we will get negative number up to weight 6. So I will copy the previous value from column 1 to 5. So I will use the formula for row 4, column 6. So the output of row 4, column 6 is max of 6 and 7. So we get the greater value, which is 7. So we put the 7 at the column 6, row 4. Same applied for the rest of the column. So let's check the greatest value of the. So now let's check if what items will be included in the bag. We have here x1, x2, x3, and x4. This represents the items here. So first, let's check the greatest value in the fourth item. So it's 8 on this column 8. Now ask if the value of 8 is included on the third item. So yes. If the value included on the upper row, we disregard the item to be included in the bag. So disregard the fourth item. Now, let's check the third item. We disregard the 8 as the greatest value on the third item. And we can get the 6 as the greatest value on the third item. So ask if the value of 6 is included on the second item. No. So include the third object in the bag. So the value of third object is 6. So the capacity minus 6, we have 2 remaining value. So let's check if the value of 2 is in the second item. Yes, it is included in the second item. Now ask if the value of 2 is included on the first item. Yes, so disregard the second item. So let's check if the value of 2 is in the first item. Yes, is it. Now ask if the value of 2 is included on the 0 item. So no. So include the first item in the bag. So we minus the value of the first item to the remaining value. 2 minus 2 equals to 0. So therefore, the item 1 and 2 will be included in the bag with the profit of 8. So the time complexity of the knapsack problem is big O of n times C, where n is the number of items and C is the maximum capacity, because you need to build a table with same size as the capacity. And that's the knapsack problem. Hope you can learn something from me. Enjoy. Thank you.